Hey, I hope you're having a good senior skip day. For right now, we are going to do a practice problem together. So we have our practice problem on the board. So if you can, just take a sec, read that, and then I'm going to walk through how we are going to do this. So pause the video if you need to, but we have these 4 C's. We got choose, check, calculate, and conclude, right? So in this kind of problem, what we need to do is we need to choose a model that represents this the best. Now, something that we see in this is we see difference, and then we also see in this example, we have samples of people. So we have 150 people, and then we have 48 out of that 100 people, and what that's going to be is that's going to be a proportion. So for this, we're likely going to be looking at a difference in proportions. So for this, we should probably be choosing a difference of proportions. So you can write that in words, or you could say P1 hat minus P2 hat, which tells us that is the difference between the proportions of people who received the new pain med and reported decreased arthritis pain, and then minus the proportion of people who were given the placebo but reported their decreased arthritis pain. So this is what we're going to be looking at for this. What we should also take note of in this is our 95% confidence interval. So just make sure that we have a 95% confidence interval. Having that written down is important for us. So what we also should do is we should be able to write down in words what this means. So this is the difference which actually I am going to say it out because I'm realizing this is going to take a lot of room to write down. So I'm just going to say it out, and if you need to rewind, that's okay. But it is the difference in the proportion of people who would report decreased arthritis pain, and then that's basically the new pain pill that they're using. It's the new pain pill subtracted, or we subtract the placebo from that. So next we got to check. We have to check the credibility of this. We got to make sure it makes sense. So first off, in the check column, we got to make sure that it is random. Now this one, we are doing random assignment. It was randomly assigned to receive either a new pain pill or a placebo. So that one, we're good to go. Next, we got our 10% rule. Now for this one, this actually does not apply because we didn't even need to use replacement or not use replacement, right? Once you pick from that, crowd of people, they were just assigned their job of either pain pill or no pain pill. So everybody was assigned something, right? So we didn't need to use replacement or non-replacement. So 10% rule is not going to be needed for this kind of model. Now we've got law of large counts. So our law of large counts, what we need to do is we need to compare proportion 1. If proportion 1 has that law of large counts satisfied, and if proportion 2 has that law of large counts satisfied, then the proportions, or the difference of the proportions, are also going to have that satisfied feature. So what we're going to do is we're just going to do our 150 times, we're going to be multiplying that probability, so it's times 0.32. And how did we get 0.32? We just did 48 divided by 150, so 48 reported decreased arthritis pain out of the 150 people. And then that has to be greater than or equal to 10, and I believe that is true. So we can put a little check mark there. And then from there, we're also going to do the 150 times 0.68. And I believe that also satisfies our law of large counts. So we'll put a little check mark for that. So that's population 1. That is for our proportion where they were given the new pain pill, and we're using the proportion of people who reported decreased arthritis pain. Now we're going to look at proportion 2. So we're going to be doing 100, and then we're going to be multiplying by 0.68. So times 0.68, right? I do believe that is greater than 10, so we'll put a little check mark for it. And then we've got 100 times 0.32. So that's also going to be greater than or equal to 10. So and I'm realizing, what did I do? Oh, I'm just mixing up my numbers a little bit. We should have had not 0.68, right? And not 0.32 for this. I was just copying the opposite of what I had for the other ones. We should have 0.21 and 0.79. So 0.21 and 0.79, right? So those do work out though. So law of large counts is good. And we are able to say that this is approximately normal. So we could say the diff of sampling distribution for our proportion is approximately normal. Right? So the difference of the sampling distributions for proportions is approximately normal for this. So now looking at the next part, we're going to be calculating. So what we need to calculate is we need to find the point estimate minus or plus or minus our margin of error, right? And that's just using our confidence interval or using our 95% to find the confidence interval. Right? So to do this, we need to solve for a couple things. We need to solve for standard error. And then we also need to look at our chart to find out what our critical value is going to be. Our critical value using our chart is going to be 1.96. So on our paper, we should see that for our P1 hat minus P2 hat, that this score or this confidence interval, we're going to be doing this plus or minus our z-score, or not our z-score, our critical value, and then times our standard error. Our standard error is going to be the square root of P1 hat times 1 minus P1 hat over n, and then we're going to be adding our P2 hat, we'll put a 1 right there too, times 1 minus P2 hat over n2. And we'll close that parentheses just because, right? So that's our general equation for that. And going on from there, we do know that our difference in proportions is going to be 0.11. The reason why we know that is because for our first proportion, we did 48 over 150, 48 people out of the 150 total people. So that was our first proportion. Our P1 hat was just our 0.32. Right? Now, for our proportion 2, when we did that, it was 21 people out of the total 100 people. So for that one, we had just 0.21. Right? If we're just finding the difference of these, 0.32 minus 0.21, right? That gives us this value right here, which is our statistic. So we've got 0.11 plus or minus 1.96 times the square root. And we are going to be just doing this whole thing out. I'll fill in the blanks, but just make sure that you are doing this carefully. We have 0.32 times 0.68, I believe, and then divided by 150. Right? Let me just check to make sure that we have this accurate. Perfect. And then we've got plus 0.21 times 0.79, and that's going to be divided by 100. Make sure we are remembering our square root at the very end. But this is how we set this up, right? This is how we find our confidence interval. Now, remember we have plus or minus. So the minus, when we subtract, that's gonna be our first number. So if you math this completely correctly, right, our first number should be 0.001, so 0.001. And our second number, so when we add that value, it's going to be 0.0219. And this is our confidence interval. Now, if you were able to follow along with that, awesome. Okay, if you weren't, you might need to rewatch the video again. You can also find a lot of resources online for this kind of stuff. If you email me, I can share you a AP Classroom lesson for it. But the conclusion is one of the most important parts. So really lock in on how we conclude or how we can state confidence intervals. So what we need to say is that we are 95% confident and we are, that word confident, the fact that we are 95% confident, that is like the biggest part of this, right? If you say that there's like a 95% chance or something like that, they will flag your answer. They will mark you as incorrect, right? So what we need to say is that we are 95% confident that from the interval of 0.001 and 0.0219. From that interval, actually I'm going to change the wording a little bit. We're confident that the interval from 0.001 to 0.0219 includes our true difference in the proportion of people who would report, and this part is literally just copying what we got in the question. So, of people who would report a decreased arthritis pain. Now, I'm zooming out just a little bit so we could see this whole thing, right? This is an example that we could very well see on the AP test, right? Where we need to use our 4 C's, so choose, check, calculate, and conclude. And making sure that our conclusion is very straightforward. We have to say that we are 95% confident that our confidence interval, or from our confidence interval, contains the true proportion. And I'm realizing that we don't know how to spell here, right? Difference. Now, the meaning of it still holds true though, right? The confidence interval, that is going to be the interval that we're looking at, and we are pretty confident, in this case we're 95% confident, that the true proportion, or the true difference in the proportions, is going to be between those 2 points. So, yeah, hopefully you're watching this, hopefully you're having a good time, or had a good time. I will see you guys on Thursday. Thanks for tuning in.